Hi, I'm Arjun, working as assistant professor in Department of Mechanical Engineering, SVT. Today, I'm going to talk about wear of metals. I'll just give you a brief introduction of wear of metals. Okay, let us start our presentation. Okay, yeah, to start with wear, okay, everyone will be known about wear. It is an undesirable removal of material from the operating solid surface, okay, or any surface, or even you can call it as the progressive loss of a substance from the operating surface of a body, which occurring as a result of relative motion whenever two particles or two components which are in motion, two objects in motion in contact with each other, okay, some material loss will be taking place. So that is called as wear, and it is an intrinsic property. It is an intrinsic property, and this wear depends on load, speed, temperature, hardness, surface finish, okay, and presence of foreign particles. So it again depends on the environmental conditions where this wear process actually takes place. And during the process of wear, okay, the materials may deform or even transfer of materials may be taking place from one element to the another element. In some cases, it might form debris, surface removal of material might take place, dents may be formed. Okay, and in some applications, as I told, the material transfer may be taking place because of the chemical reactions as a rust formation. And the general one you can see the best example is rust formation on the metals. And there are usually two definitions, okay, for this wear. One is called as zero wear, and another one is a measurable wear. Okay, a zero wear is a one where the removal of material takes place, okay, which may cause polishing of a material surfaces, okay, and it increases the performance. It is for the betterment of surfaces. It is just like a surface finishing process, where in this diagram you can see we have some rough surface which is there, and you can use some emery sheet, something like a salt paper. You can grind up this surface and you can prepare a smooth surface, something like this, and where a material loss will be very less. Okay, such type of wear is called as zero wear. Okay, it is basically a polishing process in which the asperities, means to say the particles which are present on the contacting surfaces are gradually worn off until a very fine, smooth surface develop. It is something like even you can obtain a mirror polished surface. Okay, generally a polishing in wear is desirable for better life of a tribological property and for the material. And next comes is the measurable wear. Here, a known amount of material will be removed from the surface, maybe which might cause vibrations or noise, surface roughness. Okay, any measurable amount of material will be removed from the surface. Generally, we measure where in volume or mass reduction, okay, amount of material which is lost from the material. Okay, the undesirable removal of material usually occurs in measurable wear. Okay, you can take some example where you can remove the unwanted material from the surface in a larger quantity compared to the zero wear. Okay, measurable wear usually refers to a loss of material which must be counted to estimate the life of a tribological component again. Okay, and the extent of measurable wear usually depends on the type of lubrication that we are going to produce, and the nature of load, surface hardness, roughness, and the contents, contaminants which are present in this, the type of lubricating oil we are going to use, and again, of course, the environmental properties will also be there. And it is very difficult to describe the types of because we have very, it is a wide area. Okay, the types of wear for an unlubricated metal pair, maybe under sliding contact may be termed. something like this. It can be called as a dry wear or a metallic wear or scratching wear or abrasive wear. Okay, and depending on the emphasis, okay, wear is classified into these two main categories. One category is the one in which relation to the type of relative motion and nature of interacting surfaces, and the second one is in relation to the type of wear mechanism. Okay, again, in this further wear can be again in this each type the wear can we can have different varieties of wear. Uh, Okay, if you go in the first relation where relative motion and nature of interacting surfaces, there are different types of wears. Okay, one wear during sliding friction of dry surfaces, wear during sliding friction of lubricated surfaces, and wear during rolling friction of dry surfaces, wear during rolling friction of lubricated surfaces, and the wear during the oscillating contact, and wear by moving solid particles. It may be due to erosion, it is also called as, and wear by moving fluids, which is because of the cavitations. And actually, these all of these are not applicable in the actual situations where when you have a sliding of metals against a metal, metal to metal contact will be there, and the asperity surfaces which are present on that will be lost, resulting in a wear. Okay, and if you talk of in relation to the wear mechanism, type of wear mechanism, we have abrasive wear, adhesive wear, cavitation, corrosive wear, erosive wear, surface fatigue wear. Okay, and these are the different types of wares, and this both these classifications they do not seem to be perfect because they do not cover the aspects such as type of relative motion and the interacting element and the principle of wear mechanism and normal load, friction coefficient, distance of motion, material properties relevant to wear rate, appearance to the worn surfaces. Okay, so this is about the brief introduction of this, and in the next session we will be discussing the types of wear mechanisms. Thank you.